Okay, so we're up to chapters 5 and 6. Now, chapter 5 is spanning tree, and chapter 6 is Etherchannel. So these are already up on the Cisco site. So I've got the demo packet tracer and text file. So the first part is just the setup I did to get this working. So down here, we've got a message saying spanning tree. Okay, so we've got as you can see, I've got a setup here, 3 switches. Now, at the moment, nothing's been done with spanning tree. It's all in default mode. And so they're all trunks. That's pretty much all I've done on the switches, is just configure that trunk link and these are the trunk ones. And so we've got 3 VLANs, VLAN 1, VLAN 10, VLAN 20. And so we've got hosts for each of the VLANs hanging onto those bottom switches. My monitor's not big enough on the laptop. And so as you can see, we've got 6 cables running between these switches. But if you look around, there's only 2 of those 6 that are actually active. So there's that one and there's that one. Both of these are down, that one's down, that one's down. So out of 6 cables, we're getting 1/3. So while we've got loops and we've got redundancy, that's cool. If something fails, it will, will probably work. I suppose that's a bit of a simple problem failure. But anyway, we'll talk about that later in another chapter. But yeah, so we have some redundancy, that's cool. But we've got 600 megabit links and we're only using 2 of them. So a bit wasteful at the moment. So I'll basically I'll do 2 configurations for spanning tree. I've got a simple one and one that's just a little bit different. So the simple one actually won't change much other than that one's the bridge at the moment, which is not ideal. That's pretty much your core switch. That probably should be the root one, because all the traffic from that switch, from switch 3 here, is actually going to switch 2, then up to switch 1, because they've all based their routes on switch 2. And of course, switch 1, if that was the route, you better go up there and you better go up there. So that would be more efficient again. So leaving things to default, yes, I know I intentionally made that one the one with the lowest bridge ID, I put it there. Just so I had something to fix. And so, yeah, so basically, with the simple solution, I'm playing around with the root bridge, and I'm going to set the root bridge to be switch 1. So as I said, that would be the best way to do it. Now, because it's Cisco, it uses per VLAN spanning tree, I actually have to do the commands for each VLAN. You got a question, or you good? So I actually have to do it for each of those VLANs. So that's probably a bit of a downside with the Cisco stuff, is you've got to do it for every VLAN. The upside is you can actually manipulate the VLANs and get a little bit smarter traffic movement, and that's actually what that different one is about. So as opposed to 2 out of 4 running, with that different one, I've actually got 6 out of 6 running. So so that's where per VLAN spanning tree does give you an advantage, is that it actually gives you a lot more flexibility on what you can do, and you can be a little bit more creative and actually get more efficient with it. So that's why they've gone to the trouble of it. So I'm going to make switch 1 the root of the spanning tree topologies for all 3 VLANs, and you can also sort of have a fallback, and so you can actually make it secondary. And so that would be, if switch 1 were to fail, well, switch 2 would end up being the root bridge, but of course that would have happened anyway. But I'm being a little more proactive and saying this is what I want, as opposed to just leaving it to chance of what the MAC addresses might be. So this is, as I said, this is the simple solution. So I'm just going to paste this into the switch 1. Paste. And so as you can see, there's no errors. That's always a good sign. And so now, I probably should have done a show spanning beforehand, but anyway, I forgot. you can see that the priority of this, we'll see, when you see bridge ID, it means this device I'm plugged into at the moment. But you can also see that it's actually the same as the root bridge, and it actually tells you here, this is the root bridge. So, yeah, I probably should have done a spanning tree before to to look at it before I changed it, but forgot. Anyway, and so now you'll notice that on all three VLANs, VLAN 1, this is the root bridge, VLAN 10, this is the root bridge, and VLAN 20, that's my simple solution. And so now you'll notice that everything is centered on switch 1. And so the two ones across the bottom are now disabled. And so you've got a link going up for each. And that, to me, looks like a much better traffic solution for the network. So the traffic from switch 3 will go there, and then up to the router, of course. Now this, so you've emailed it to me? Yep, right, cool. And so this one here actually won't change anything at all because the root bridge is already the root bridge. I actually don't, I'm not really fixing anything, but as I said, I'm sort of being proactive in the way that I have a fallback root bridge, basically. Now, in this little topology, the difference between switch 2 and switch 3 is negligible, but on other networks, there would be a much more likely candidate to be a secondary bridge. And actually, when we do Chapter 9, we actually look at first top router standbys. I'll actually go into it, and it will be a much better all-encompassing redundancy setup, redundant routers as well as redundant core switches, as well as access ports and access switches and all kinds of redundant links going everywhere. So that would be a more ideal setup on actually how you would set up a reliable network. This is just a little bit on the small and sort of rinky-dink size, but anyway. So yeah, we just need to carry on. Now, as I said before, yes, the traffic is being routed a little more ideally now, but we've still only got 2 links active. 4 links have been deactivated. So, you know, we're not getting value for money out of those ports and cables at the moment. So let's have a look at an alternate solution. And so because we've already done some configuration on S1 and S2, I actually have to undo some of that. That's why I've got these no commands here. So what I'm going to do is I'm going to have switch 1 to be the route for VLAN 10. I'll have switch 2 to be the route for VLAN 20, and I'll have switch 3 to be the route for VLAN 1. And so switch 1 will be the secondary for VLAN 20, switch 2 will be the secondary for VLAN 1, and switch 3 will be the secondary for VLAN 10. So I'm sort of sharing the load around. And so as I said, this is an alternate one. It's a little bit crazy. In the real world, you wouldn't do it this way, but it's just a bit of a simple demonstration on how you can actually, with a little bit of creative thinking, sort of share the load and also I will actually have all 6 links active once I've gotten through all this config. Now, because I hadn't done any spanning tree on switch 3, I didn't have to undo anything, so that's nice. Now, go away. Let's speed up time a bit because spanning tree's probably a little confused at the moment. But now have a look at that. All 6 are running. So basically, VLAN 10 is centering its efforts around switch 1. VLAN 20 is centering its efforts around switch 2, and VLAN 1 is centering its efforts about switch 3. And so that has actually gotten all 6 links up. And so basically the traffic will be flowing different directions depending on what VLAN it's in. And so it's basically sharing the wear around the network, or sharing the load, I suppose is probably a better term. And so that's, I'm going to say, as I said, this is a rinky-dink little network. And when we do chapter 9, I will demo a real good solution on how you can do these things. But yeah, we can sort of have a little bit of a play and have a look at that. And so that is cool, and that's why per VLAN spanning tree has some advantages. It uses more resources, it takes more configuration, but it does have some upside as well. And so you can get very smart with it. Now, of course, that's spanning tree itself I've played with, and I haven't actually looked at spanning tree on this one, have I? Here, you'll notice that spanning tree enabled protocol IEEE. So that's actually the original spanning tree is what that's running at the moment. So if we do a show run, spanning tree mode PVST. So that's per VLAN spanning tree. It's actually 802. I've lost the number now. Version D. I can't remember the number now. It slipped out of my head. Anyway, so version D. Rapid spanning tree is version W, and yeah, so the original is version D. And so you can see here the commands that have gone in. So I did primary and secondary. If we look at switch 1, I set VLAN 10 to be primary. And you'll notice that it actually has this priority value of 24,000 roughly. Secondary gets a value of 28,000. And of course the default value is in the 32,000s. And so that's basically what happens is you do primary and it will set a number that will make it most likely to be the root switch. Secondary sort of somewhere between that primary and the default value. So that's your fallback switch. And so that's what it does. But of course, this extended system ID is where it uses the VLAN number as part of that priority setting as well. And so just a little bit different so that you get a different priority number for each VLAN typically. I haven't done much else here. The first 4 links are what? So this is 1 and 2 for switch 1, and this is 3 and 4 for switch 1. So that's why they're trunk links. We'll actually undo that with when we do Etherchannel. VLAN 10 is hosted on port 10. VLAN 20 host is on port 20. And yeah, of course this is switch 1. That's the trunk link to the router on a stick. So that's basically all I've done with those switches really. Before we got to it, I'd just assigned I'd created the VLANs. I'd assigned 2 ports to those VLANs, and I'd made the trunk links. That's all I'd done. Now, there's a bit of extra stuff that we haven't done from spanning tree yet. Now, we can actually do the spanning tree mode rapid PVST, and so that's a per VLAN rapid spanning tree protocol. So 802.1W. And I'm also doing Portfast. So we've looked at the chapter, I take it. So Portfast is basically turns spanning tree off on that port. Now, the reason for doing that is actually with rapid spanning tree, there is a port type called edge port, which basically means it's a host port. And so you don't actually need spanning tree on host ports, and that's what I've done here is I've just set these 2 ports to be port fast because hosts these days boot a lot quicker than they ever did, and the 30 to 50 second delay that spanning tree gives you can sometimes cause problems with DHCP. So the host will boot, send a DHCP message out while the switch is still in listening and learning mode, and so won't forward those packets, and so you won't get an IP address. So bit of a downside. So that's basically the things I'm doing. I'm changing it to rapid spanning tree, and I'm getting Portfast going on those 2 ports. Now, you should never use Portfast on links between switches, only to the hosts. And so, as you can see, if we go up to the top, when it comes to those host ports, are actually, where is it? The switch port mode access have already done that. So that's something you should do. Manually assign it as an access port. Don't let it go dynamic. And then if you do the Portfast, you won't have any troubles. All right, so let's paste this extra stuff into the 3 switches. Now, you'll notice that wherever this Portfast command has gone in, it gives you a warning. Basically the same warning as what I've already mentioned. And so, yeah, use with caution. Don't throw that command out willy-nilly. So, rapid spanning tree. Yeah, no error message, must be good. Of course, spanning tree is probably going to be a little bit confused until we've got all of them running the same version, but so again, all right, let's give it a bit of time. Of course, all 6 ports should be up because it's still got, I haven't played around with the primaries and secondaries, but let's have a look at show spanning tree. All right, so you actually have changed, it said IEEE before, now it's saying RSTP. It's still an IEEE protocol, but that's just the way they differentiate them. And so VLAN 1, the root ID is that. This one's ID, of course, is the 32,000, so this is just another switch on VLAN 1. On VLAN 10, of course, this is the root bridge. Again, it's running rapid spanning tree. So that and that, of course, it's all identical stuff because it is the root bridge. On VLAN 20, the root bridge has a priority of 20,000. This one has a priority of 28,000. So this is the standby. And of course, it was switch 2 that we set as the root bridge. Now, you'll notice that the interfaces that are listed here are the 4 fast Ethernets because they're the trunk links bouncing around. And of course, this is switch 1, so there's also this, which is, it's sort of treating as a trunk link. Well, it is a trunk link, I suppose, but oh God, don't do that. Windows. It's actually the one that's going up to the router. So now, when we play around with Etherchannel, these ports will actually all change. So, Etherchannel is our next topic. So, if we do a show run, yeah, so I've set the first 4 ports to trunk ports. Now, with Etherchannel, if you've looked at the chapter, basically the best way to do it is actually have the minimum possible configuration on these individual physical ports, just so that they'll be identical. Because to get port channel running, all of their settings need to match. Speeds and the trunk status and, you know, allowed trunk VLANs, all of their things have to match perfectly. So probably the best plan is have the minimum possible configuration on the physical ports. So the first step I'm doing is actually getting rid of the configuration I've got in there. So I've got no switch port mode trunk. So it's going to blow those away. And then, so interface range, I suppose that's probably the first time that's been mentioned as well in this chapter. It's a wonderful thing. Saves you having to go into each individual interface. It's a beautiful thing. I bet you're wishing you'd seen that last subject. But anyway.
That last one. You did mention that.
Did I? Okay.
Week 6 of the show.
Oh, okay. Well, it's a great thing. And so if you've got a security policy in your organisation that says all unused ports will be on VLAN 13, you know, that unlucky VLAN that goes nowhere, and you know, shut down. Interface range, fast Ethernet 0/1-24. Switchport mode access, switchport access VLAN 13, shut down. Bang, you can do it on all the ports, and then the ones that you need, you then change them to be what it is. So it's a great way of doing something on bulk ports, bang, in one hit. Wonderful plan. So I'm taking away the trunks on the 4 ports. Then I'm making the first 2 ports a member of one channel group because the first 2 ports go to one switch. The second group of 2 ports go to a different switch. So they can't be a member of the same channel group because they're different channels. And so we've got channel group 1 and channel group 2. They now have 2 new interfaces, interface port channel 1 and interface port channel 2. And in them, I've made them trunk ports. So again, the only command in those ports is this command. Now, I haven't really spoken in specifics about this command. So channel group 1, of course, refers to port channel 1, channel group 2 to port channel 2. And then, of course, there's mode. So this is all negotiated. Now, there's two protocols available. So PAGP, which is Cisco proprietary, it's got 3 options available: on, desirable, or auto. And so, of course, if both ends are auto, it won't be a channel group. If both ends, or at least one of the ends is desirable, it will become. And of course, on is manually on. Now, PAGP, as I said, is Cisco proprietary. There is LACP, which is standards-based, and that's what I've actually done. So there's active, passive, or on. So actually, on is the same. It's actually not different between PAGP and LACP. It's just manually set to a channel group. No negotiation. So active, of course, is the same as desirable, and passive is the same as auto. And so at least one of the links need to be active. I've been lazy, I've made both ends. But anyway. And so, yeah, so that's what I've done there, just the 2 different groups. And of course, this will work nicely. The number doesn't need to match from one end of the link to the other, but yeah, they need to be in the same group. Yeah.
Got a question.
Yep.
Why is it called Ethernet channel when every time in the iOS it's called port channel?
I don't know. I think it's just, well, whether they thought it would be easier to, so you can just do P or PO or something and hit tab and it will, if you do Ethernet, well, there's real Ethernet interfaces as well. So I'm not sure, but it saves a little bit of sort of commonality, and so you can abbreviate something a little easier. That's my only thought on it, but that's what I've figured out for myself. Whether that's the reality is another thing entirely. All right, so switch 3 we're doing first apparently. So we've taken away the trunk modes, we've added the ports to the 2 channels, and then we've configured the channel modes. So there's lots of interface changes there. So the interfaces have gone down, they've gone up, we've created a couple of port channels. So hopefully in the end it'll all be nice. So that's 3. Got to do 1 and 2 yet. So again, a lot of messages. All right, let's just fast forward a couple of times and see how we go. All right, let's do a show run. Let's see what went on there. So as you can see, no, it's very strange. Anyway, so as you can see, these I wasn't expecting to see the switch port mode trunk commands in there, but anyway,
In the real switch, you don't see it.
yeah. So channel group 1, these are in channel group 2, and of course these are those new interfaces that have been created, the port channels. And so these are actually the ones that will appear in spanning tree as well. It won't actually, remember we looked earlier, it had fast Ethernet 1 through to 4 in there. They actually won't be in there anymore. All right, not much else has changed in the config. So let's do show Etherchannel. And so we've got two groups, group 1 and group 2. We've got, it's a layer 2 configuration. There's 2 ports in it. The maximum ports is 16. And as you can see, it's running LACP. Now, all right, I've done summary now. And so we can actually see the status. And so port channel 1, status of SU. So S means it is layer 2, it's an uppercase S, and U means it's in use. And then for each of the separate ports that are members, capital P means port is in a channel. And so away you go. So that's certainly some good information. So that all seems pretty happy. So let's, if we do show spanning tree. So this is switch 3, so it doesn't have the gigabit link to the router. We now just have the port channels. Now something I probably didn't mention in when I was talking about spanning tree is all the different port types. Now this is switch 3. It is the root bridge for VLAN 1. And so that's why you don't see any root ports. It's because it's the root bridge. It doesn't need a root port. It is the root bridge. While designated port means it's active, at least on this end. But of course, when it comes to oh God, stop doing that. When it comes to VLAN 1, of course, these are all single ports now as far as spanning tree is concerned. You know, this is the root port, so these 2 ports would be active. These would be, this one would actually be the disabled one. So that's fine. On the other VLANs, now VLAN 10, of course, has a host on it, so don't have to worry about that. Now, we have a root port and a designated port for VLAN 10. Now, VLAN 10, from memory, switch 1 is the root for that. So I'm assuming the root port, of course, would be, I'm assuming this port here. If I went back and had a look at 3 and 4, yeah, 3, 4. So that is correct. Now, VLAN 20, again, it's got a root port, but it's the other port. And so, because switch 2 is the root for that, and so that's the active port. And so, yeah, that's the alternate port. So, you can sort of, so typically for me, designated ports are normally on the other end of a link from a root port. So let's just say this is the root bridge. this will be the root port pointing towards it, so the other end of it is a designated port. Now, of course, the redundant links, normally only one of the ends is being made alternate, but yeah. And so alternate, of course, that status means it's blocking, which means it's not in use. But of course, it can change very quickly. All right, so that's pretty much all I was going to look at. So we got Etherchannel running. We did a lot of play with spanning tree. That's pretty much it. Are there any other questions on those topics at all?